Inverse of the matrix tutorial. Inverse of a number. In normal addition, the number meets its inverse. The result is 0. Example, 10 plus of minus 10, which is the inverse of 10. It gives 0. And in the same way, in normal multiplication, the number meets its inverse and the result is 1. Example, 10 into 1 by 10, that is the inverse of 10 in multiplication, which is equal to 10 into 10 inverse and is 1. In matrix multiplication, a matrix meets with its inverse and the result is the identity matrix. For example, this is the square matrix A and this is the inverse of the square matrix A, that is A inverse matrix, and the product of these two matrices is the identity matrix. Let A be a non-singular matrix if there exists a square matrix B such that A and B is equal to identity matrix, then the matrix B is called the inverse of the matrix A and is denoted by A to the power minus 1. Inverse of a matrix is calculated after calculating the determinant and the adjoint from the matrix. Here are the steps. First of all, we have to find the determinant value of the matrix A, and the second step is to find the adjoint of the matrix A. We will be calculating the inverse using the determinant and the adjoint of the matrix. To calculate the inverse, we have to use the formula, that is A inverse is equal to adjoint A divided by the determinant value of A. Let's take an example. Let's find the inverse of this matrix. This is a square matrix, 3 by 3 matrix. 1 3 1 1 1 2 2 3 4. First of all, we have to find the determinant value of this matrix. Let this matrix be A. To find the determinant, first, this is the first element, A11, and take this element and let's leave the row, first row and the first column, because this element 1 belongs to the first row and the first column. Leaving this, we take the other elements 1 2 3 and 4. We have to cross multiply the leading diagonal of these 4 elements. First 1 into 4, and we have to subtract it with the secondary diagonal, that is 3 into 2. 1 into 4 minus of 3 into 2. After this, we have there should be a negative symbol, alternate positive and negative symbols, because this element lies in the first row and the first column, and is denoted by I plus j is 1 plus 1 for this number. I represents the row and j represents the column, and this negative sign should be here because with this value we have that is this value we have to multiply minus 1 to the power I plus j. I represents the row and j represents the column. So 1 into 4 minus 3 into 2 minus 1 to the power 1 plus 1, and then it becomes positive. But in this case 3, and the value will be the negative because minus 1 to the power 1 plus 2, and it is a negative. Similarly for the 1, this is positive, negative, positive, negative, positive, negative, and positive. At last we have found the determinant value as minus 1. Now we have to find, the second step is to find the minus of A. Minus of minors are calculated leaving out the row and the column in which the element belongs to. Minor of 1 is represented by M11 and it is calculated without this element. We have to cross multiply 1 and 4 and subtract it with 3 and 2. In case of determinant, we have multiplied the value with this element 1, but in case of minus, we have to leave this element also along with this row and column. We have to take only the rest elements, that is 1, 4, 3 and 2. Similarly, M12 is the second element and it is denoted by M12. Leaving the first row and the second column, we have to multiply 1, 4 and subtract it with 2 and 2. In the same way, we are going to calculate the minus for M13, 21, 22, 23, 31, 32 and 334. Matrix of minors. From the minor values from the matrix A, we have to form another square matrix with the values we have got from that minors. That is minus 2, 0, 1, 9, 2, minus 3, 5, 1, minus 2. These are the values we have got here. Minus 2, 0, 1, 9, 2, 3, minus 3, 5, 1, minus 2. Next, from that matrix, we have to calculate the cofactor matrix. Cofactors are the signed minors. Position, with the position we have to calculate the cofactor, that is minus 1 to the power I plus j into M11 or Mij. For the first matrix, minus 1 to the power 1 plus 1, first element 1 plus 1 into M11, and it is the same because minus 1 to the power 1 plus 1 is a positive, so it remains as if, that is minus 2. But in the second case, it becomes negative, and third case it is positive, in the fourth case it is negative. In the same way, we have to find the cofactor for all the elements and the next step is to form the adjoint. Adjoint is the important, so we have to form adjoint. This is calculated from the transpose of the cofactors, that is, these are the cofactor values and we have to transpose this first row into first column, second row into second column, third row into third column, and we have got this adjoint. This is how we form the adjoint matrix. And the final step is to find the inverse of the matrix. As told before, we have to use the formula A inverse is equal to adjoint A divided by the determinant A. Value of adjoint A is this minus 2, minus 9, 5, 0, 2, minus 1, 1, 3, minus 2. And the value of determinant is minus 1, as we found it already. From this formula, we have found that the inverse of the matrix A is 2, 9, minus 5, 0, minus 2, 1, minus 1, minus 3 and 2. Thank you.